In this video, we are to find the unbiased minimum variance unbiased estimator for an exponential distribution using the Cramer-Rao inequality. For more on this topic, you need to subscribe to this channel. Solution. The first thing to do to find the minimum variance unbiased estimator for an exponential distribution is that we recall that for the Cramer-Rao inequality, we have the Cramer-Rao inequality to be 1 all over n multiplied by the expectation of the derivative of the log function of our given PDF all over the phi all squared. So this is our Cramer-Rao inequality. What do we now do? It means that this is our PDF that is given. Also, the next thing to do is to find the log. We differentiate with respect to phi. We take our square. We also take the expectation and multiply by n. Whatever we get, we now compare it with the Cramer-Rao inequality. So, if f of x phi is equal to phi multiplied by the exponent of phi x, if this is our PDF, then we say take the log. Take log. If we take the log of this function, if we take the log of this, we'll get ln phi. We'll also take the log of this. It will now be, the exponential sign will go. We'll have phi multiplied by x. So the next thing to do, we've succeeded in taking the log, which is this ln function. The next thing to do is to differentiate with respect to phi. So we say differentiate with respect to phi. So we have the differential function of our log function all over the phi to be equal to, if we differentiate this, we get 1 all over phi. If we differentiate this with respect to this, we'll get just x. That is what we'll get. So if you watch out, we have the whole of this as this. So the next thing to do is to take our square. So we can write it as the differential of our log function of the given PDF all squared, which is this square. We'll now write it as 1 all over phi minus x raised to the power of 2. So from quadratic equation, we can simplify this to give us 1 all over phi squared minus 2x all over phi plus x squared. This is what we get. So the next thing to do is to take our expectation. So we can write it as n expectation of the whole of this, the differential of our ln function all over the phi squared to be equal to, we take our expectation to be 1 all over phi squared minus 2x all over phi plus x squared. So we succeeded in taking our expectation. The next thing to do is to open the bracket. So we'll move over to this other side of the board. If you find this video helpful, you need to subscribe to this channel. So we'll move over to this side of the board. Now, we have n expectation of the differential limit function pi all over pi all squared to be equal to, if we open the brackets, we'll have something like 1 all over pi squared minus 2 into expected value of x all over pi plus the expected value of x squared. So this is what we get. We should recall that for Poisson distribution, the expected value of x is equal to 1 all over pi, while the expected value of x squared is equal to 2 all over pi squared. So this is what we get. The next thing to do is to substitute the values for expected value of x and expected value of x squared into wherever we see them here. So we have this as equal to 1 all over pi squared minus 2 multiplied by expected value of x is 1 all over 5. 1 all over 5 multiplied by 1 all over 5. Because here we have 1 all over 5 already. Sorry, 2 all over 5. Now our expected value of x will give us 1 all over 5 plus this 5 that is here, which is 1 all over 5. Now plus we have expected value of x squared to give us 2 all over pi squared. So this is what we get, which is also equal to the n multiplied by the expectation of our differential log of our given function all squared. So we move over here and rearrange this. We'll move over to the next side of the board. If you find this video helpful, you need to subscribe to this channel. So we can have it as n multiplied by our expectation, our differential log of the given function all over the pi squared into, now we have 1 all over 5, 1 all over pi squared. Also, we have 2 multiplied by this will give us minus 2 all over pi squared plus 2 all over pi squared, which is equal to 1 all over 5. Of course, this negative this plus this will give us 0. So we have 1 all over 5 remaining. So the next thing to do is to multiply by our n. Because the whole of this will give us 0. So that is gone. So multiplying with our n, we have n into our differential log of our given function all over the phi squared will be equal to, as we are multiplying with n, we have multiplied with the expectation before, which is what we got here. Now we are multiplying with n. This is the value we've gotten. If we multiply this with n, we have n multiplied by 1 all over 5, which is equal to n all over 5. So the next thing to do, like I said earlier, is to compare it with the Cramer-Rao inequality. So comparing with the Cramer-Rao inequality, we have comparing with Cramer-Rao inequality, we have 1 all over n expectation of differential log of our given function all over the phi all squared will be equal to, we already have the whole of this as n all over pi. So if we take the inverse of this, we'll have it as pi all over n. So this value becomes our minimum variance unbiased estimator for the exponential distribution using the Cramer-Rao inequality. So this is how we can simply obtain the minimum variance unbiased estimator for the Cramer-Rao inequality of an exponential distribution. If we follow these processes, it will be very easy for us to compute the minimum variance unbiased estimator. For more on this topic, you need to subscribe to this channel to get more videos on Cramer-Rao inequality.